Hi guys, this is Joseph D here. Welcome to another one of my videos. Today we're following through what we were doing last time with making an adapter for these motor end shields to go on the lathe. The adapter's now being made. As you can see, a good look at it. There are 4 Allen screws keeping this part together. What it is the motor end shield is being mounted to the adapter plate by 4 Allen screws, which are just shy of the depth of this. The reason for that being is this face has got to be slightly machined down, and these screws must not catch in the cutting tool. So as you can see, they're slightly below the surface. Now what I need to do is to install this into the lathe chuck. That'll be clamped like so, and then we'll go from there. Okay, so our motor end shield now is mounted into the lathe via an adapter which has been specially made for this purpose. There's 4 Allen screws which are securing this piece to the adapter plate, and this adapter plate is chucked into the 3-jaw chuck with the outside turning jaws in place. Now I'll just try it and show you. It spins okay, relatively square. Now what we need to do is to bore this part out hollow for the motor stator to go. Now in case you're wondering what a motor stator is, the motor stator is this piece here, this piece with the windings on. That's the stator, and that's the rotor, which has the drive shaft for the motor pushed through. These are usually pressed together. It's usually a drive shaft which is a long piece of steel that's like this, and it's pushed through with a hydraulic press and then machined down. The end of it's machined down to whatever profile it's required for driving whatever equipment it's going to be driving, i.e. pulley or anything else. Usually sometimes this shaft has a flat on it milled for a grub screw to hold a pulley on or whatever it's driving. Now what I have to do here is I have to take out that diameter from the motor end shield and always bore a recess that's like that, but I have to leave a piece in the middle which will be to hold the bearing, which is, in this case, it's a bearing like this. It's a 600Z bearing. Now there's 2 of these that go in each motor end shield, and we have to just start boring this away carefully. Now to make it easier, the first thing I will do when boring this is to face this area down first with the facing tool. So I'll do that and then I'll come back to you in a second. Now facing this piece down, a very fine amount is taken off. Excuse the shakiness, I have to hold the camera as well as do the turning because I've got no camera tripod yet. But we face this level first before we bore it out. So I'll just continue this and then I'll come back in a second. Right guys, this has been faced up beautifully. All the outer part is all perfect. This inner part doesn't matter because this is going to be bored out, but you can see it's looking pretty decent. I bore it to about up to there, so 60mm from there to there. So if I get my ruler, I'll have a look. $65mm we want it. So it's about there. You'll see more when I can start to bore this out in a second. Before I bore this out, I'll just show you my inside turning tool which I've ground down this morning. I've ground a special tool just for this purpose. just to bore out these motor end shields. So hopefully this should work. I have another tool which is in there, which is, you know, just a facing tool and boring tool, but this is the right tool for the job, this one. So this is what I'm going to use now. Okay, boring tool is now installed in the lathe and is set up to bore out the work. Close up view. I've just left a slight margin from the end, which will make this inner diameter less than 65 millimeters. This will be finished off to around 65 millimeters when I'm near the end of the process. So I'll make a start now and start boring it. It's just very gentle. That's all you need, just a slight touch. Same again. Now this will go on for some time. The first initial bore has got to be about 10 millimeters deep. Then a different tactics is used to bore just a little bit between there and there. Now we have to leave, that's the reason for this, is we have to leave a recess in the middle, which will be where the bearing is supposed to go. So I'll bore this up to 15 millimeters deep and then I'll come back to you in a second and I'll show you what I mean. Just an update on the boring progress. Carry on with this and then I'll update the video for the latest stage in a minute. Back again. So far I've been boring this. I've bored it about 5 millimeters deep with no problem whatsoever. As you can see, the casting is good. It's free from air bubbles or any gas bubbles or anything, which is a good sign. So what we need to do next is to drill out this center part here. We have like a little tiny pip in the center, because my cutting tool is just shy of center height. I've packed it underneath here with a piece of aluminium to raise it slightly, but it's still just a fraction off, which doesn't make much difference. But in order to overcome this, I will just use this drill and drill roughly a hole through. Center hole now drilled to aid with the boring of this motor end shield. Now when I come to the center, from here to the center, I've got no pip anymore because I've drilled a hole right the way through and into the adapter plate, which is not a problem. Alright, this has been bored deep enough now to up to where the hub is going to be, the bearing hub. I will continue hollowing the outer part of this down a few more millimeters, but the center part will be left, which will be the place that accommodates the motor's bearing once I bore that through. But there's a good look at it. Not bad. back in a second. Now boring out the area for the bearing to fit. This will be done until I reach the required depth that the bearing is, and then I will widen it to the exact diameter of the bearing. So this bearing that's up here pushes in as an interference bit. Bearing recess now bored out, so the bearing is a nice interference bit. Perfect. That just gets pushed together when the motor shaft gets pushed through here, when the motor's assembled. But that's your bearing. Nicely done. Now the next thing is to bore a slight hollow around the bearing hub. Now this hollow has to be bored about 10mm up to around where I've got my finger there. We mustn't bore any deeper than that, otherwise we'll weaken this, and we don't want to do that. Hi guys, lathe is now being set up differently to bore the opposite side. So I've put the lathe in reverse. I'm going to start to make our hub. That only goes so far. Then I'll put the lathe back in reverse and finish it the opposite way round. A lot of chatter that can't be helped, but you see what I'm trying to do? See that? That's your hub for the bearing. Now this part here gets hollowed another few millimeters deeper. That gives clearance for the windings of the motor, which, if I show you, is this area here has to have enough clearance. The hub of the bearing goes in the middle of this winding, and for the motor drive shaft to come through. But these windings have to have a slight clearance for them to fit comfortably inside the motor end shield once I put it together. The lathe is backing forwards again, and now I'm boring the opposite way round, so they both meet. I come this way. They should meet. And they meet. Now I keep doing this process until I've got the area deep enough for the windings to fit comfortably, and then I'll come back to you once I've done this. Right guys, all the machining is finished now. I've just got one last tiny piece to machine, which is just a little tiny lip on here, like a recess. Now this recess allows this motor stator to locate into the motor end shield like a dowel, so that way it doesn't move around, it just locates central for the motor to fit together snugly. So this is the last bit I'm going to do now. Hi, motor end shield now is bored and finished. Motor stator fits, has a tight interference fit. And another motor end shield comes from the opposite way to clamp together with long Allen screws that keep it together. But it locates neatly into that recess, and it looks like an electric motor now. All I have to do now is machine another one identical to this, which will be for the opposite side. But the only thing is, that one will be drilled in this area here. There'll be a hole drilled there for the wires to come through, which is, because this is a multi-speed motor, there's multi-wires that come through, which will be to a control box or whatever to control this motor. It's a 3-speed motor from a Willow-Simpson pump, water pump. First setting is 65 watt, the second setting is 110 watts, and the third setting is 130 watts. Nice little motor, which I've salvaged. And I'm hoping to put it together to use it for a machine tool project. The motor end shield is now machined slightly larger, so the motor stator stays in this place. Before it wasn't staying, it was falling off. So it's just a tight interference fit. And the same on the opposite motor end shield when it's on the other way. There'll be another one the same as this that makes up the whole motor. So thanks for watching my video, stay tuned. I hope to do more fun videos like this. Just the last part of this video is just a follow up. This is the motor end shield when it's all been bored out. Not bad, eh? This should encourage many fellow casters out there. Next will be to face this area up on the lathe, bore that hole out slightly bigger to allow for the motor drive shaft, which will be about 12mm. And that's basically it. That's just the motor stator there, rotor, and this part, as you can see, the motor stator fits inside there as it should. And that's the location for the bearing, which will house the drive shaft of the motor, for the motor to drive whatever it's going to be working. Pretty cool, eh? Thanks again, viewers. Take care of yourselves. Bye. Just a supplement to the existing video, here I decided to machine the face of this motor end shield using a smaller lathe to do the job. So here we go. This only requires fractions taken off, as it's quite square. Just very slight amount. Just hear it catching. Just so the motor can mount precisely onto whatever it's going to be driving. Just midgets, just very slight amount taken off. I'll continue this and I'll come back to you in a second once this is done. The face of the motor end shield has now been turned down nicely. The last stage is to just bore out the hole in the centre where the motor shaft will come through. So here I go. I use a 12mm milling cutter because I find this works best. The hole has already been pre-drilled to 8mm. So just gently bore that through. This has been a fun metal casting project and I'm very pleased with the results. Once I feel that breaks through, then I'll stop. By the way, this is the same lathe that's in my other videos. So just if you want to know more about it, click on my other videos and you'll see it when I first got it. It's always handy in the workshop to have more than one lathe set up to do different jobs. So that's through. Well, almost. Perfect. I'll say that's a job well done. Worth all the effort and the time. There, look at that. Just as good as the factories. From my very own backyard. Laugh out loud. Thanks for watching, guys. Take care of yourselves and I hope you have fun whatever you do. Cheers, bye.